Part of me wants to go ahead and get started, and part of me wants to say some people are going to miss the most provocative portion of the talk. So, we'll go ahead and start. We have one talk in this section before lunch, and then there's lunch, there's the plenary sessions, which will be held in here, there's another break, and then we'll have both the Meet the Press with Bob McGonigal, as well as the open forum later this afternoon. I'm Stephen Hewitt. I'm at the National Cancer Institute, where I'm chief of the Tissue Array Research Program and Applied Molecular Pathology Laboratory. And I'm going to talk about where we need to take whole slide imaging. This is my black box warning. This is a joke, flat out. The FDA has black box warnings, and these are what you need to know before you go any further. I'm, quote, an employee of the federal government. I'm actually an officer in the Public Health Service. I serve a role in the Association for Pathology Informatics. I work closely in CLSI on consensus for IHC assays, so that's my background. And I've been a consultant to the FDA on this subject, but I'm also a collaborator on this subject. I'm going to talk about this a little bit during this talk. So, we have a problem. This is the problem. It's a big problem. Now, I'm going to leave it up to you to decide who are the Larry Flint and the Hugh Hefner of digital pathology. But that's the problem we're facing today. Here's where we need to go. We have to stop just looking at our images and saying, oh, they look good. Basically, it's like exactly as I said, and the problem is you're so enamored with looking at it, you're not even looking at your glass, which is the real thing sometimes. So we need to take digital pathology and make it a tool that's useful for all of us to move forward with. It's an enabling technology, it's very clear. But medicine is complex and it's regulated. And it's currently on the sidelines. And we're only going to solve this if we all work together, the users, the vendors, and the regulators. So we have different perspectives. Sylvia also described it as faster, better, cheaper. I always say it's better, faster, cheaper. It's a splitting of hairs. I think it's great that we have the same paradigm. Obviously, the FDA has their paradigm: intended use, safety, and effectiveness. So let's talk about the FDA. They were invited to be here today, and management wouldn't let them be here. And I'll be honest, I'm frustrated about it. These are some of the things that I have learned. Excuse me, management of the FDA. Let's be clear, yes. Management of the FDA. Not the foot soldiers at the FDA, but the management of the FDA. So one of the great pearls that was given to me by a medical officer at the FDA is the FDA is a reactive organization. They only react to what is presented to them. Think of them as a macrophage, if you will. So if the vendors don't go to the FDA with filings, the FDA is like, well, what's the issue? Okay. Now, there is a draft guidance in works. We know this. When are we going to see it? I wish we knew. It has two halves, and I'll talk about those a little bit in a minute. But what it does do is it defines metrics. It doesn't tell you the methods. So we're hearing a lot about, well, the FDA has said this and the FDA has said that. Not all of that's 100% accurate. Now, unfortunately, sometimes the FDA runs their mouths and people either don't hear them correctly or take it as gospel. And what a person says at the FDA may not reflect the policy or the actions of the FDA. Clearly, the FDA speaks a foreign language called regulatory science. And this is something they actually talk a great deal about internally, in learning how to speak and understand regulatory science. And if I had a Rosetta Stone or some other tool to help you understand it, I would. I'll give you a little bit of insight into it. So these slides, I got about 4 or 5 of them here, are actually taken from the regulatory panel that was presented at Pathology Visions last November. They were taken from the FDA slide deck because if you work for the government and you present it in public, it's public. Okay? So these were Tramel's slides, and she started with what is a medical device. She gave this example. She pulled this out of the in-flight magazine as she was flying in. And, and comments that a clinical intended use would make this a medical device. Now, I'll point out that had there been an eyepiece in here, it probably would have been a very different beast. If that had just been a digital camera on top of a microscope that you could look through the eyepieces of, it might not be. But in the absence of an eyepiece to carry out the actions of it as a microscope, to them it's a medical device and it needs an intended use, or has an intended use. This is their definition of safety, and the red is theirs, it is not mine. But you need to see certain words there: probable benefits and probable risk. Safety is measured with reference to probable. So if you gain a great deal in one aspect and you lose a little bit in the other, it may not be such a big crime. Effectiveness. Clinically significant results. My favorite was, I was at an FDA statistical meeting. I'm not a biostatistician, but I get invited to these for whatever reason. And somebody asked the FDA statisticians, for which they fall into multiple camps, how much better than 0.5 on the ROC curve do I have to be? And the FDA's response was, 0.51? Maybe 0.5. Are you 0.5 every time? If you're 0.5 every time, maybe you're better. So I think people misunderstand effectiveness. Now, you should always remember, safety comes before effectiveness. It's in that order, but people misunderstand effectiveness. This is the last slide, and this is an important one, and this is very complex, even to me, and I've looked at the slide for years now. This is how the FDA has dissected the whole slide imager. And basically what they're saying is, slide goes in one end, and instead of light hitting your retinas, a lot of other things happen. Okay? Now, they have, and this is their text. I'm going to come back and show you the logic behind their text, because this has been a source of substantial misunderstanding in this space for quite a while. So here is the FDA's logic about whole slide imaging. The microscope predates the FDA and is hence exempt. The stethoscope is exempt. A lot of things are exempt. Tissue processors for histopathology are exempt. Microtomes are exempt. They predate the regulatory. Aspirin is an exempt drug. It predates the FDA. You have to remember that's their regulatory agency. Viewing an image on a screen is not the same as observation by a microscope. I think that most of us actually do agree about this. Okay? So, therefore it's subject to regulation. Okay, so they've said this is our logic, this is how the law works. How did it get to class 3? Don't use the word decision, it's statutory. There's only one path in. If you're subject to if you're new and you're subject to regulation, you start at class 3. You can't start at class 2, you got to start at class 3. Can it be downstaged? Absolutely, and we'll talk about that in a moment. So this is where it gets really interesting. What does the FDA not say? And when the FDA doesn't say something, it really kind of means, guys, it's okay, you can do this. Be careful, watch yourself, but we're not patrolling this zone. Frozen sections are something they don't care about. And somebody asked earlier, was a frozen section a primary diagnosis? In the context of the way the FDA thinks about it, a frozen section is a preliminary diagnosis because somebody is going to review the permanent section thereafter. It has known risk and failings, and hence the use of digital pathology in that context is not bothering them. One reason is they run a safety effectiveness measure on it, and they say, is it any more unsafe than performing a frozen? Probably not. Does it really improve patient care? Pathologist is at home not having to come into the hospital, or the diagnosis gets rendered in a more rapid fashion. Yes, you've really obtained some substantial effectiveness. Okay, let's look the other way. Consultation. The pathologist who's signing out the case in the hospital is going to put his name on the paper. If it's a breast cancer and the consultant says, no, it's a pigmented melanoma, hopefully the pathologist looked through the slides and made sure that he looked at the right slides and won't sign it out without making sure it's exactly the right thing. Again, another example where they believe that whole slide imaging is improving health care, improving timeliness, better, faster, cheaper. Now, I'll share an interesting anecdote with you, and that was there was recently on the API listserv a question about who could run an automated microscope for whole slide image or for frozen diagnosis telemedicine. And I took the posting and I forwarded it to the FDA. The names shall remain silent. And what'd you think? Came back, huh? I think anybody could run it. Basically, anybody who was competent enough to determine that the tissue that had been submitted for frozen section appeared on the slide, which means you're histotexing your residents, was more than competent to run the telemicroscope for the pathologist in the back end. So there is a great deal of common sense being applied here that I think people miss. It's not always true, but I think there are instances. So LDT, self-validation. FDA works with what's used as the total test concept. I'm going to come back to this later. But an LDT is defined as the assembly of different components into a test. And a validation has to incorporate all of those components, whether they are individually validated or not. So the logic the FDA applies is if you buy it as a single package from a single vendor front to back, it can't be an LDT. That would be like a HER2 test with a 510K clearance. If, on the other hand, you choose your antigen retrieval, blah, 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 for your ER, you're not running it as a 510K. And if you are assembling your whole slide system and are willing to validate your whole slide system, in theory, one could, in the United States, perform primary diagnosis on whole slide imaging. I actually asked them specifically. I walked up and asked them, I said, you mean I could do this? And they looked at me and they said, yes, Stephen, you could, because I use software from one vendor, hardware from another vendor, and a number of other features. And I could march through and do exactly that. That's the good news. Bad news, I've done that. Didn't work. So there are some issues here to be addressed in the future. One of the key things is you have to have a defined standard. I should come back to that some more. So what are the challenges? Well, the FDA is driven by data, and what they define as data is what they define as data, not what you define as data. And it really becomes what is the intended use in the context of primary diagnosis. Is it cancer? Is it not cancer? Is not sufficient. The example I always use is breast cancer. You got to get the margins, you got to get the lymph nodes, you got to get the lymphovascular invasion, and you got to get the grade. Anything that's going to affect the way the patient is treated that is substantially changed and is outside the boundaries of the variability that one would see in inter and intra-pathologist reproducibility is what they're going to aim for. Now, they acknowledge there's intra and inter-pathologist variability. We all know about this. Sometimes it's high, sometimes it's low. But the paradigm that they're concerned about is a sudden shift of, let's say, 20% decrease in identification of micrometastasis. If you saw a 20% decrease in micrometastasis detection in breast cancer in the United States in lymph nodes, it might have a substantial difference in patient outcomes. That's what they're worried about. So they put it in terms. They put it in that terms. Now, obviously, from a risk management point of view, my concern has been, if somebody does this and it's not well validated, we could all lose. I don't want to see somebody who thinks they've validated a system do this in their own shop, turn around, get sued, lose horribly, and then take a vendor down with them. And that's really at risk. And you think I'm kidding, but I think we should all have been paying attention to the news in compounding pharmacies. And that's exactly what's going to happen in that instance right there. What's the gold standard? Well, I don't think any of us really know exactly what's going to come out. What we do know is that you have to define it a priori. You can't perform the study and change your mind and do a post hoc analysis. That's what they're really not going to settle for. And they want to know what your adjudication process is. Those are the two critical things. Washout, I don't know what they're going to do. I wish I did. But I do know that they're going to look at a priori, did you define what the metrics are, can you defend them, and two, what's your adjudication. Whether you do intra, inter, gold standard, I think there's a lot of space still left on the table. But that's the word think. Listen to my words. And then there is guidance on how you should power the sample. The study, it's in CLSI IL-28A2 appendix. The secret, it was written by the FDA, so they'll take it. Okay. So here's a description of the battle or the discussions that have gone on with the FDA, both in the panel and within the FDA, on how they would go through the citing what can and cannot be approved. And obviously the organ-based approach has really met a great deal of disfavor. I think John Sinnard doesn't like it. I don't like it. A number of people really don't care for it. It's uncertain what's going to happen. The FDA wants to take derm and heme and cytology off the table. I'm not sure I 100% agree with them, but we need to get started, so let's get started. I will put forth that looking at biopsies as a starting place is probably one of the easiest places to go, because if one uses, for example, the CAP checklist and applies it, one discovers that the number of things that can be applied from the CAP checklist to biopsies is exceedingly limited, whereas if you're trying to apply the CAP checklist to whole organ specimens, it's an extensive list and makes powering the studies much more challenging. I think that a frontal assault on whole slide imaging trying to deal with mastectomy is a very challenging issue, but a frontal assault of, let's do colon biopsies, and then let's do prostate biopsies, and then let's work our way up to pancreas and breast is a very feasible approach. And I encourage people to consider that strongly. So let's go back to fit for purpose for a minute. Fit for purpose is a model that the FDA uses that's basically evolution. Has the test evolved in a fashion to meet the needs of the test? Or did you take something off the shelf and say it's going to work fine? And what we discover when we go back and really look at things is that most of the medical technologies that we use, even those that existed before regulation, have evolved very carefully to meet their purposes very, very specifically. If you look at the evolution of the light microscope over the last 150 or 200 years, you see a very straightforward evolution and improvement in function to meet our utility that we actually rapidly adapt. And so I think that using this paradigm is extremely useful. It also has other benefits because it works within the life cycle structure and allows you continuous improvement. And if you make a small change, you don't have to revalidate the whole object. You revalidate only those elements that you've made a small change in. That's a critical issue because clearly people have been concerned about, well, if I change this, I'm going to have to revalidate it. No, you need to revalidate what you changed, not the whole instrument. And that sometimes can be done in a technical fashion, not in a biologic or clinical trial setting. Again, a source of confusion. So here are some examples of fit for purpose and whole slide imaging. And there are different ways of dealing with it, both with reference to the imager and the software and interface. And clearly the FDA is thinking about hardware versus clinical performance as two separate entities, and people need to keep that in mind. It's also a starting point for the vendors. You can go in and deal with hardware pretty cheap before you have to confront your software or your clinical trials. And that will get you a great deal of learning and information. And there's nothing worse than doing a clinical trial and then discovering that your hardware's got to be rebuilt. There are a lot of assumptions that are going to be made. I'm going to make a shameless plug for my postdocs poster later this afternoon because it's going to debunk or at least try and address some complex questions that we really haven't addressed correctly. The FDA is doing research in this space. It's under the Critical Path Initiative. They've been funded to actually do research. I'm collaborating on this. And we have built a beast of an instrument. It allows us to make a whole slide image and present a field of interest on that whole slide image and then match it under the microscope exactly. Now, they're not going to be seen together side by side, but rather a reader would have a session where they would see the field of view with the microscope. And then the same field of view would be presented to them in a digital image. And it's going to evaluate things like color, spatial features, and those other elements, trying to understand color resolution and focus and their importance in whole slide imaging. In our preliminary efforts to build this system and develop those tests, we're pretty certain that actually there are going to be some examples in which the whole slide imaging system is going to flat out win. There are real advantages here that we're not capitalizing on, and we need to. And so here's an example where the FDA may come forward with a win before the rest of us do, and that's frustrating. So we're still looking to move forward. This is my castle in the sky. This is Canyon de Chelly. This is White House. So when is good enough? Well, I think that this really gets to the critical issues that we have to confront in whole slide imaging today, and it's not the FDA, but it's the economics of the business and how we can move whole slide imaging forward with a steady model that people will want to adopt. The FDA is very dedicated to improving medical care through technology, but that only is going to get adopted if it makes financial sense. So our cost of whole slide imaging are time, money, and quality issues, and our benefits are pathology staffing, throughput, and new tools to improve our function. I view it as me, pathologist. It's got to help me do my job better. So a lot of people have used different economic models. I've had a tendency to put this economic model down, digital radiology versus digital pathology, because there are substantial differences. One was a replacing technology versus an additional technology. That said, I've changed my mind a little bit. Here's digital mammography. It's had a very long road, and it is very, very successful. And we should adopt this model, and what we can learn from it is part of our roadmap. It's widely accepted now that digital mammography is better than films, okay? Why? Technologically, they're able to see more features. But what's really happening now is breast tomosynthesis is going to replace digital mammography because it even offers more information to the radiologist to find those lesions. What's even more interesting about this than that is every instrument that's currently on the market only needs a software change to use breast tomosynthesis. The machine already can swing. It's already there. So you see how in a correctly leveraged system, we can go from using a microscope to digital microscopy to computer-aided or whatever you want to do if we deploy this correctly. The negative is this example, the compounding pharmacy example. I think everybody's read about it in the paper, but it's an example of a small niche that avoided regulation. And I'll be honest, 13,000 units of steroids for injection in 3 lots sounds like manufacture to me. And it's going to result in major changes. And this is when the systems don't work right. This is going to negatively impact all of us. I don't know how many of you have ever had medicines compounded, but it's like a pendulum. It goes from one direction to the other. We want to stop that pendulum from doing this back and forth and keep it in the middle, keep us weighted. So I've torn up a lot of stuff. I've been a little nihilistic. Let's try and be a little bit more positive. Whole slide imaging is enabling. People talk about efficiency. Dr. Assa showed about efficiency, but she also talked about how much staff she was using to do this. She had techs that are scanning. It does provide integration. It's hard to put a dollar value on integration. It does provide quality assurance. Unfortunately, we don't bill for quality assurance. We should. And so, unfortunately, I'm forced to look at computer-aided diagnosis, CAD and those tools, as our real efficiency gains. Yes, there's efficiency in dollars to be made and benefit in efficiency, integration, and quality assurance. But we've got to move forward and offer more for this technology to succeed. And I'll show you the numbers in a few minutes. So we're in the middle of a clinical trial ourselves right now using whole slide imaging. It's Neptune. We're studying nephrotic syndrome. And we've got about 160 biopsies to date, and it's been a really interesting learning platform because what we're learning is even when it's a nightmare, there are big gains to be had. I'm getting a rigorous quantitative lesion-based review of nephrotic syndrome. We're going glom by glom. Not only are we going glom by glom, but when we have multiple sections, we are aligning them and we know that this glomerulus is this glomerulus in this level, and this level, and this level. We're counting them and tracing them. So that's where my gains are, and they're substantial gains. In theory, this has the opportunity to really revolutionize aspects of nephropathology, especially nephrotic syndrome. But But what are my challenges? Well, one, it's a clinical trial, so getting from a biopsy to glass that the pathologist can review on the digital systems is taking 6 months because you got to make the hospital happy, you got to get the nurse to send you the slides, you got to collect all the information, scrub all the HIPAA information off and everything else, and it's about 6 months from biopsy to it's posted on my website. We're an enormous amount of QA effort, and it's requiring substantial staff. I think we underestimate the amount of time our staff are devoting to these technologies. What is his biggest weakness? And I'm going to come back to this later, is the variability in our stains. This is possibly what is going to is undermining a lot of whole slide imaging. We don't acknowledge it today, but if we improve it, the field will move much, much faster. So I think this actually hits on most of those points. One of the things that we've discovered is that most centers lack the IT infrastructure to manage their images effectively. I was running one of the scientific sessions this morning, and one of the speakers was talking about how they were having trouble with their network and couldn't share on the network, and were having to use a vendor-provided service to accomplish this. This is the norm. We have to confront our IT needs, and our IT needs are extremely expensive. Until we get there, we're not going to be able to move to the next steps. I've talked about the staffing issues. And the flip side is the cloud's working. I have to say that I have been dumbfounded with the speed, strength, and stability of my cloud servers. That's the good news. The bad news is I really hate backing up a cloud. It takes a lot of effort. So, looking at it from a cost level, we think it's actually cost neutral in a clinical trial setting compared to the round robin where you're going to send a box of 100 slides to 10 different pathologists, and compared to the cost of taking 10 pathologists, shoving them in the conference room and torturing them for 2 days. I've run the numbers, and I think Dr. Asa hit a real economic number earlier, and that is the cost of shipping. You really have to look at these numbers, and the shipping adds up real quick. I talked about the co-registration with the levels, and that's a real benefit, and we're going to develop scoring systems. So I'm excited about this. I'm ready to dance. Those are Apache and Gallup at Intertribal a few years ago. So we're going to have a lot of transformation. We're going to have transformation in our histology labs, IT, and in the pathologist reading space. And it's going to add up to big dollars. Now, in this meeting, it's easy to talk about transformation in IT because most of us are already focused on IT. That's good. The bad news is this is IT on turbocharge. And if you're running an LIS and you've got a couple servers, maybe a staging server and a backup or something, a running server and a backup and some storage, well, my installation is 4 active servers, 4 staging servers. I had the first 64-bit VMs in the NIH. So it took me a lot of fighting to get where I got, but it tells you how much you need. Clearly, the pathologist reading space is going to change, and if you've ever been in enough pathology labs, you know that pathologist spaces don't change too often. So it's going to be an interesting situation. This is the chicken and the egg. How are we going to improve our stains in a fashion that is going to really make whole slide imaging as robust as it needs to be? I work with CLSI. I talk to and I'm on the phone with the Biologic Stain Commission, but no one is really actively day in and day out in a large-scale fashion doing exactly this. It's going to require input from us, from the reviewing pathologist, the histotechnologist, and the manufacturers to accomplish this. The number one stain that causes me trouble in the clinical trials is the silver stain, but don't go looking at the trichromes. They're pretty bad too. The H&Es are a little bit better. But we have to overcome this in a concerted fashion to really move ourselves to the next level. Image generation is the next challenge that we're going to face, and it's got production rate issues and it's got quality issues. It really has to be measured of slides that are ready for review off the scanner in a fixed rate. It can't be how fast I can scan the slide. You know, if you can scan it fast and I can't read it, it's not helping me. And it's also got to incorporate the downtime on the instruments and everything else. This is where it gets tricky. Image presentation. I've separated scanning from presentation. What we're finding right now is that the speed of getting it on the screen and the speed in which he can pan it across the screen are fundamental to success with whole slide imaging. Now, some of this is going to change as we change the way the interfaces that we're using. The mouse may be going away. But we really need to improve this to the Google 0.2 seconds. That's Google's estimate of what somebody is willing to wait for a search. And I think that's a good estimate of how long a pathologist is willing to wait for his slide to load, because they know in my lab I'm much faster than my software. The viewing environment I've already touched on, and again I've already touched down on downtime. Image curation. We've been kind of sweeping this one under the rug. Oh, it's like, well, I'll just have more drives, more drives, more drives. Well, okay. There was an article, I think it was the New York Times, maybe it was the Wall Street Journal a couple days ago, about zombie servers. 20 to 50% of all server farms are servers that are sitting there doing nothing and consuming vast amounts of electricity. We cannot afford that. We cannot afford to be maintaining 10 years of archive on active spin for on-demand access. You know, you go to your hospital administrator and you tell him how much you're going to spend on keeping 10 years of slides available on demand, he's going to laugh at you. We also have to figure out how to integrate this with our LIS and our electronic medical record. I can see a role for providing a great deal of information in our images in the LIS, but I'm going to gag if I see another photo of a clinician in the clinic pointing at a screen. I don't believe whole slide images belong in the electronic medical record. It's not to say I don't believe images don't belong in the electronic medical record. I just don't believe whole slide images belong in the electronic medical record. And so these are some of the things we're going to have to address. Other things we've got to sort out, well, we've got to figure out this image format problem. What are we going to do about the image format? The courts are going to have their opinion on what's a legal image. CLIA may have their opinion, and the FDA seems to have an opinion. I'm not sure I know exactly what the FDA's opinion is, but I do know that the courts have decided that a TIFF is a legal image. And then some courts have probably decided a few other things, but they like certain features of the TIFF. The question is are the formats that we're using for whole slide imaging going to meet these standards? And if not, what are the costs to us when we're trying to run whole slide imaging? If they decide we have to use lossless compression, this is a game changer. We're going to have to redesign some stuff. How long are we going to have to store the glass? How long are we going to have to store the images? Now, all of a sudden, everybody says, well, I'm going to save money. Well, no, you may actually be spending more money. These are water dancers from Acoma. They're in search of water. I'm in search of answers. So let's talk about some practical models. We all know that pathology is a low-margin industry, and we're going to have to improve productivity to implement this technology. This is my back-of-the-envelope calculations for the cost of employing whole slide imaging. Okay, and it was very interesting to see Dr. Ass's numbers in the way they've deployed things, because they were actually relatively congruent given the number of pathologists and cases at any given site. Okay, but this is how I estimated what you're going to see out in a moment. I'm assuming your instrument's going to last 5 years. I've got some that haven't, but I'd like to say they will. And this at least gives you some cost basis for this. Now, I should also clarify, because I didn't put it on here, the staff cost basis on this is a histotech average salary of $50,000, okay? And a pathologist average salary of $250,000, okay? So when I did my forecasting about gains in productivity, I basically took the cost of a pathologist and I added a certain percent. So if he was going to have a 10% gain in productivity, it was a $25,000 value in gain productivity for one pathologist. 5 is obviously 12.5. And so that's reflected in the slide after this one. This is Badger's Law. It's a little bit of a private joke, but Roger Badger was Moore's PhD advisor. We're all familiar with Moore's Law about CPU capacity. Roger would say, look, guys, this is all great, but cost ain't going down. cost of whole slide imaging is not dropping because every time you get a new toy, you're demanding more out of it. So for people to assume that all of a sudden cost in whole slide imaging will drop, I don't think it's going to hold up. Whoops, I talked a little bit about this a minute ago. Value added. Okay, I can only speculate what we're going to develop as value added tools in CAD. So where's the graph? This is the graph. So the red line is the estimated cost of implementing whole slide imaging in pathology groups of different sizes. 1 pathologist, 5 pathologists, 10, 25. And at least between 10 and 25, at 10%, or 10 pathologists, the cost of whole slide imaging is about 17% of the remuneration of the pathologist. And at 25 pathologists, it drops to 14%. Okay? So you see that it starts to level out. You do get some improvement as you go with large scale. But this graph clearly demonstrates, I'm not saying it's perfect, but it's at least a straw man for discussion, that we're going to have to find on the order of a 15% productivity per pathologist to make whole slide imaging cost neutral. CAD obviously is only going to be a fraction of it, but I argue that telling me that QA, efficiencies, presentation, and workflow are not going to add to 15%, especially when one starts to address fatigue issues and other issues that clearly can occur from staring at these monitors. Now, I think it does argue very convincingly, though, that in the large setting and possibly the reference labs, this model makes a great deal of economic sense. And I think Dr. Asa's talk demonstrates an example where you can't afford to keep a pathologist in a distant location because of a salary or workload patient. The metrics suddenly change. What are you doing? You're concentrating your pathologist and you're using your technology to bring this in. And it does work. But it is marginal. We have to focus on this productivity model. So where do we go from here? Well, I think we need better instruments, quite honestly. I've spoken in other venues, and I think I showed some of the data here last year, but some of the instruments on the market really don't hold up to some stringent testing. I've broken pretty much everything I touch in a good way or a bad way. I'm not saying what I think it needs to be in a second-generation instrument. In fact, I think that needs to be an open discussion. And I'm not certain exactly all the features, like Z-Stack. I'm not sure. We need calibrators, and I'm going to come back to that in another slide in a moment. We need to develop our models of image management, and we really need to focus as a community. This is the community that should be focusing on productivity gains in whole slide imaging. So I said I was going to comment on the phantoms. I'm the research chair for API. People that are interested in participating in this effort, please contact me, hunt me down at the meeting, or send me an email. But we're interested in developing both an XY phantom, which allows you to make sure that the machine runs in its full grid fashion, a Z phantom, and a color phantom. Again, earlier, one of the scientific sessions today, they had employed some phantoms in the European trials, and we've tried some of those phantoms, and they have certain benefits and certain challenges. Obviously, my group is interested in this. The FDA is actively interested in an open collaborative forum. I've been contacted by people at GE, and actually GE corporate, not Omnics in this instance, because they're interested in fluorescence, Philips, Visiopharm. And I'd love to have a few more academic collaborators as well. So, and with that, I'm going to end. Thank you.
As a histochemist and a founding member of ISAC, the International Society for Advancement of Cytometry, I'll point out that we got flow cytometers through, and that is a more difficult instrument than what you have, because there was no experience on that, and for some reason they made monoclonal antibodies class 1. So there is, because no one could figure out all the combinatorial changes, so there is hope. We have experience with controls. Our credibility is based on fluorescent beads, if you want to know the truth. When you see that the CV of the beads is less than 2%, it says that machine is working. and you keep that data, and you can show that there's quality. And I think you're putting the cart before the horse. I think at the last slide, you got to the point. What the FDA wants to know is, does this damn machine work? And you have another predicate instrument, which are the Pap smear readers.
I think you have a good point, and it's interesting because in some fashion the FDA is trying to separate exactly that and say, let's deal with the instrument, then let's deal with the clinical studies, because their feeling has been the instrument isn't ready for prime time, and then let's go address its intended use.
And I will point out one obvious thing, it may hurt your feelings, but I bet that instrument, any one of them, is in better focus and optical alignment than you people normally set them up, because we know that you usually do not have coiler illumination, even though that's changing when you use white light LEDs, but we don't know.
You won't hurt my feelings, because I've had them go, why do you want your microscope collimated? Because X, Y, and Z. But you're absolutely right that it's a problem.
And the flatness of your illumination is not flat. In fact, in fluorescence, we have a hell of a time trying to get the illumination flat. As for hematoxylin, you can't say that to a professional histochemist. We will tell you DAPI every time, but do your own thing, even though we could phony it so it looked like hematoxylin for you. But what I will tell you is the secret is chicken nuclei. For years, I hate to say we were chicken flickers, but anyway, we took DAPI-stained chicken nuclei and used them as a calibrator. There's no reason why you can't put the hematoxylin-stained chicken nuclei and see what your CVs are on those machines.
Most of my instruments won't image fluorescence.
No, I'm taking hematoxylin-stained chicken nuclei.
Yeah, you can do that.
And there is at least a predecessor of this, so you have some idea. And then, in absorbance, you still have to have compensation. Your blue isn't only measuring hematoxylin, your red is certainly not only measuring eosin. So the machine at that point beats the normal setup. And you also could make a good three-dimensional phantom to see how good your autofocusing is.
So I wanted to comment also on the issue of histology quality, because we as pathologists, I think, have accepted poor quality for far too long. And those of us who do consults know the range of what comes out of histology labs. So I would argue that we should be demanding from the manufacturers or ourselves creating CAP accreditation regulations based on image analysis of slides as part of a histology lab accreditation. And I mean, your point is very well taken. These are things that should be standardized. There should be controls. That's what I meant by the Westcard rules for pathology in my slide. Slides coming out of a histolab should all be evaluated, and that's what a scanner should be doing before it sends to the pathologist. I see that as becoming part of what we need to have for our setup.
I think your suggestion of incorporating it into the CAP checklist is probably a really good suggestion. I'm not sure the CAP checklist is willing to bear the teeth that it might need for that, but if we match it to the instrument, it's going to gain those teeth. It has to meet the dynamic range requirements of the instrument. We routinely see slides that are too faint and don't ping any dynamic range, and then others that are too overstained and have maxed out the dynamic range in a fashion that makes them imageable. I will also comment that the slide sets that we see that are the most problem, again, are the scatters, the DABs, and the silver stains. Those are the critical ones, and they undermine the focus systems.
So I also wanted to just agree with you about not incorporating the images into the EMR. I think that's really going to be dangerous down the road, so congratulations. I do have to disagree with one of your points, though. I don't know how many folks in this room have actually done time analyses of looking at slides in a microscope versus looking at them digitally. The systems that are out there today, when they're set up properly, in our hands are actually faster. You can open an image and move around that image faster, and we've done this. We did parallel studies of time to look at a case, both ways, looking at digital first and looking at slides, glass slides first with our group, and we are either at a par or faster on digital.
And actually, I've looked at the software you're using, fastest software I've seen. I wish my software were that fast.
What are the macro manpower implications of what you're talking about? Are there going to be more pathologists or 15% fewer pathologists as the population ages? Is this going to be a safety valve, or what's up?
Well, it's a tough situation. The United States has a relative lack of pathologists right now. We have a shortage. But if you look at us, we're the best off in the world. Yeah. Somebody was laughing. There's no doubt that the United States has got the healthiest number of pathologists. And in fact, Africa, I think you pointed out yesterday, has the dearth. Your numbers were higher than mine. I always say you can count all of them in sub-Saharan north of South Africa on two hands. But and it's a real critical problem. I've even heard people posit of onshoring histopathology to the United States because we have more pathologists. The question is how are we going to deploy our pathologists more effectively? And I think that Phil Quirk at Leeds has been focused on this. Obviously, Sylvia's group in Toronto is focusing on this. And I think that this is going to be the magic challenge, is not necessarily getting us more pathologists, but deploying our pathologist in a more useful fashion, rather than having some pathologist who's reading, 20% breast, 20% ovarian, and 60% general. If they really are a breast ovarian expert, let's put them in a situation where they can do that. The subspecialty sign-out is taking hold pretty strongly in this country. And I think there's good reason for it. And I think that this is an example where whole slide imaging may really enable more aggressive use of subspecialty sign-out, and that you will gain efficiencies. Clearly, there's going to be a balance in terms of the efficiency for the pathologist, in terms of the number of cases he reviews. Regardless of the speed of the systems, there's going to be a fatigue factor. And we can go back and look at the fatigue factor studies within cervical cytology before the introduction of the imaging systems, and now going back and looking at it after the introduction of the systems. And there's a big argument as to whether the imaging systems that are now in cytology are going to require an alteration in those numbers. And so I think it's too early to tell exactly where we're going to fall out. I think a better question is, why aren't people choosing pathology? Why is it that radiology, which is in a dark room, is sexier than pathology? So, any more questions? I hope I've caused you to think. I hope I've educated you. Hope you'll come back and hear the open discussion. It's time for some lunch. Thank you.
Yeah, but I'm saying as the issue when the vendors don't want to do any of it. That's no.